Yes, students, all of you, good evening. Welcome to the session. Is the screen is visible?
Yes, sir.
Yes. Students, continuation of network theory concepts, two-port networks. With respect to two-port networks, in the previous sessions, I discussed all these topics. It's already completed. Who are not attended these sessions, once again, please go through the recorded classes. Yes. Different types of parameters, how to calculate the different types of parameters that I discussed. Then what is the condition for reciprocity and symmetry also I given. Then interconnection of two-port networks, I explained in detail. Please go through all these points. Yes, friends, and I solved some models of questions that I already covered with respect to two-port networks. Then one more important topic with respect to two-port networks is relationships between the parameter sets. That is various parameter sets. What the relation? For time being, I don't want to explain. I don't want to derive all the relations. Just I will give some idea, one or two parameters. Then remaining relations directly I will give one tabular column. But no need to by heart that tabular column. If you want, then you can try to remember that tabular column. Or otherwise, how to convert, how to represent one parameter in terms of other parameters. Just one or two parameters that I will explain. For remaining parameters also, you please go through that procedure only. For example, see, students, Z parameters. If you want to represent Z parameters, yes, in terms of Y parameters, Z parameters in terms of Y parameters. Yes, that means once you know the Y parameters, how to find the Z parameters. Once you know the Y parameters, how to find the Z parameters. Yes, friends. One method is, here I am giving the tabular column. All these. You please try to by heart this one, or otherwise you can try to method I am explaining here. Whatever the convenient you are feeling, that you can follow. Yes, friends, Z parameters in terms of Y parameters. That means you want to calculate the Z parameters by knowing the Y parameters. That means what you can do? First, you can write down the Z parameters. What are the Z parameters? V1 equal to Z11 I1, yes, friends, plus Z12 I2. Then V2 equal to Z21 I1 plus Z22 I2. This is the Z parameters. Then what are the Y parameters? I1 equal to Y11 V1 plus Y12 V2. I2 equal to Y21 V1 plus Y22 V2. Now see the friends, in order to compare these two parameters, you convert these Y parameters, these relations. Actually, Z parameters are written voltage in terms of current. Voltage in terms of current. Now, you can also write these equations voltage in terms of currents, because this is current in terms of voltages now. But if you want to write, if you want to compare these Z parameters in terms of Y parameters, means you also convert, because Z parameters are voltage in terms of currents. That's why you can convert this also into voltage in terms of current. Then see, from this one, I'm writing like this. Shall I write like this, friends? Y11 V1 is equal to I1 minus, yes, because you want to write voltage in terms of currents. I1 minus Y12 V2. Y12 V2. Okay. Y11 V1 equal to I1 minus Y12 V2. Is it okay? Now voltage in terms of currents that I want to write. Then I want to replace this V2 by I2. V2 by I2. Then how we can replace? Yes, from this one. What is from this equation? What is Y22 V2? Y22 V2 equal to I2 minus Y21 V1. Is it correct? Y22 V2 equal to I2 minus Y21 V1. Then Y11 V1 equal to I1 minus Y12. What is V2? I2 minus Y21 V1. Clear, students? Now you convert this one. Y11 V1 equal to, yes, I1 minus Y12 I2. Y12 I2. Sorry, just a minute, because I want to write V2 now. Then from this, what is the V2? First you can do this. What is the V2? V2 equal to I2 minus Y21 V1 by Y22. This you want to substitute Y22. Okay. Y12 by Y22. I am multiplying into I2, minus into minus plus. Y12 into Y21 by Y22 into V1. Okay. Then this you can bring this side. Take the V1 is common. If V1 is common, Y11 minus Y12 into Y21 by Y22 is equal to I1 minus Y12 by, this is Y12 by Y22. Y22. Is it okay, students? Then I'm simplifying like this. V1 into, can I multiply like this? Y11 into Y22 minus Y12 into Y21. Y12 into Y21 by, this is Y22, is equal to I1 minus Y12 by Y22. This Y11 into Y, where Y11 into Y22 minus Y12 into Y21 is equal to delta Y. Then from this, what I can write, students? V1 into delta Y by, what is this value? Y22. Y22 is equal to I1 minus Y12 by Y22. I1 minus Y12 by Y22 into I2. Then from this, what is V1? V1 equal to Y22 by delta Y into I1 minus Y22 Y22 cancel, Y12 by delta Y into I2. Okay, this is the V1 in terms of I1 I2. But you know that V1 equal to Z11 I1 plus Z12 I2. This is, you know, because I want to write the Z parameters in terms of Y parameters. This is, we know that. Now from this, what is the Z11? You tell the students. What is the Z11? Then you compare these two. This indicate the Z11. Then Z11 equal to Y22 by delta Y. What is delta Y? That you know. Then what is the Z12, students? Z12 equal to minus Y12 by delta Y. Is it clear? Minus Y12 by delta. Like this, I derived the Z12 and Z11. But you know that Z12 equal to Z21. Z12 equal to Z21, or otherwise, this I derived the Z1 and Z12. Then in order to derive the Z21 and Z22, you want to write V2 in terms of which one, students? V2 in terms of I1, I2 you want to write. Okay. Now see, we know that what is V2. Next, what is V2, students? What is V2 from this one? V2 equal to I2 by Y22, I2 by Y22. This equation I am writing. I2 by Y22 minus Y21 by, is it Y21 by Y22, Y21 by Y22 into V1. This is equal to I2 by Y22 minus Y21 by Y22. But what is the V1? That is V1 equal to, this I am writing. From this one, what are the V1 students? I1 by Y11, because this V1 I want to eliminate, because we want to write V2 in terms of I1, I2 now. V2 in terms of Y1, Y2 you want to write. This is into V1. This V1 I am writing from this one. I1 minus Y12 by V2, that is I1 by Y11 minus, this is Y12 by Y11, Y12 by Y11 into V2. Okay, now yes, you multiply this one. What is V2 equal to? I22 by I2 by Y22 minus Y21 by Y21 by, that I am multiplying, Y11 into Y22 into I1 minus into minus plus this Y12 into Y21, Y12 into Y21, Y12 into Y21 by Y11 into V2. Now you bring this V2 this side. Take the V2 is common. Then what we can get, students? Is it correct? This I am writing I2 by Y22. This is into I1. This is Y12 into Y21 by Y11 into Y22. Yes. Y11 into Y22. Then take V2 is common. Y11 into Y22 minus Y12 into Y21 by Y11 into Y22 Y1 is equal to, first I am writing this term, minus Y21 by Y11 into Y22 into I1 plus I2 by Y22. Then from this is the delta Y. Then V2 into delta Y by Y11 into Y22 is equal to minus Y21 by Y11 into Y22 into I1 plus I2 by Y22. Now from this, what is the V2? Y11, Y22 cancel, minus Y21 by delta Y into I1 plus Y11, Y22, Y22 is cancelled. Then delta Y by Y11 into I2. Yeah, this is the V2 equation. Clear, friends? Now you compare what the V2 I am getting. V2 equal to minus Y21 by delta Y. Just idea I am giving students how to convert from one parameter to another parameter. Minus Y21 by delta Y into I1 plus delta Y by Y11, delta Y by Y11 into I2. Then we know that what is V2 equal to Z21 I1 plus Z22 I2. Now we compare these two. Then what is the Z21? The Z21 equal to minus Y21 by delta Y. Minus Y21 by delta Y. What is the delta Y, that you know? What is the Z22? Z22 equal to delta Y by, that is Y11 by delta Y. Is it correct? Yeah. Please make this. If we bring this side, just small correction. Okay, this is Y11, students. If you bring this side, this is Y22 is cancelled. Delta Y goes to denominator. It is delta Y by Y1. Now this is correct. Now this is delta, sorry, Y11 by delta Y. because delta y goes to denominator, no? This is correct. Now here also you can change this small. This is one method how to convert from one parameter to another parameter. Then what is the Z22? Z22 equal to y11 by delta y. Y11 by delta y. Clear? Okay, like this we can write the Z parameters in terms of y parameter. Like this, any parameter you can convert. For example, if you want to write y parameters in terms of z parameters, then what you can do? All the z parameters we can write v1, v2 in terms of i1, i2 in terms of v1, v2 you can convert. Then you can compare. Understand, friends? For example, write ABCD parameters, write ABCD parameters in terms of z parameters. If the question is asked like this, just idea I'm giving, then what you can do in terms of z parameters? ABCD parameters is v1 i1 in terms of v2 i2. This is v2 i2, but z parameters are i1 v1 v2 in terms of i1 i2. Then if you want to compare this one, you write all these z parameters v1 i1 in terms of v2 i2. You convert this v1 i1 in terms of v2 i2, then you can compare these two, then you can get the ABCD parameters in terms of z parameters. That is the procedure for every parameter. Then by doing all this, then I'm not giving every derivation, not required. This is the final conclusion. Yes, friends. Just now I derived this one. What is the Z11 equal to Y22 by delta? What is the Z12 equal to minus Y12 by delta Y? What is the Z21 equal to minus Y21 by delta Y? What is the Z22 equal to Y11 by delta? Just now I derived this one. Clear? Now, what are the Z parameters in terms of T parameter, ABCD parameter? What are the Z parameters in terms of T dash parameters? What are the Z parameters in terms of G parameters? In terms of H parameters? Sir, what is the delta H, sir? What is the delta T here, sir? Simply remember, I'm giving a generalized formula. Delta X equal to X1 into X2 minus, delta X equal to X11 into X22. Generalized formula. X11 into X22 minus X12 into X21. For example, what is the delta H? Delta H equal to H11 into H22 minus H12 into H21. Clear, friends? What is the delta T? Delta T equal to, then we can do this one. Delta T, that is AD minus BC. Understand? What the delta G? Delta G equal to G11 into G22 minus G12 into G21. Like this is a generalized formula. Okay, students. Then you'll see the Y parameters. This is the Z parameter in terms of all the parameters. Now this is the Y parameters in terms of all the parameters. Y parameters in terms of Z parameters, Y parameters in terms of ABCD parameters, Y parameters in terms of T dash parameters, in terms of H parameters, in terms of G parameters. Next, ABCD parameters with respect to other parameters. ABCD in terms of Z, ABCD in terms of Y, ABCD in terms of T dash, ABC in terms of H, in terms of G parameters. Sir, how we got this? This is the concept only. Whatever the procedure I follow, please follow that procedure. You can try to derive the every formula, or otherwise, maximum you try to remember this also. Next, don't remember, maximum you concentrate Y parameter, Z parameters, and ABCD parameters and H parameters. And T dash parameters and G parameters are not that much of important. Now this is the T dash parameters in terms of other parameters. What are the A dash in terms of Z, B dash in terms of Z, C dash in terms of Z, D dash in terms of Z. Now what is the A dash in terms of Y? What is the B dash in terms of Y? What is the C dash in terms of Y? What is the D dash in terms of Y? Like in H parameters, like in terms of G parameters, in terms of T parameters. Next, H parameters with respect to all other parameters. H parameters in terms of Z, in terms of Y, in terms of ABCD, in terms of T dash parameters. Then H parameters in terms of which parameter here it is missing that I am writing. Please concentrate. Yes, that is G22 by delta G minus G12 by delta G minus G21 by delta G, G11 by delta G. Next, G parameters in terms of other parameters. What are the G parameters in terms of other parameters? All this you concentrate. This is a relationship between the various parameters. This concept is also important for computer exams. Next, one more topic. Open circuit and short circuit impedances. What do you mean by open circuit impedances and short circuit impedance? The name itself, it indicates that open circuit impedances means by open circuiting the input port and output port, if the parameters are calculated, then it is called open circuit impedances. Short circuited impedances means if the parameters are calculated by short circuiting the input and output ports, then it is nothing but a short circuit parameters. Okay. Clear, friends? Now, I want to give the generalized formulas for open circuit and short circuit impedances. Yes. Yes, friends, what are the open circuit impedances? Let the open circuit impedances can be written as at input port and at output port. This open circuit impedances can be written as at input port and output port. With respect to input port, the open circuit impedance equal to Z10. That is written as V1 by I1, V1 by I1. At input port we are calculating means at output port is open circuited, I2 equal to 0. Generally this is Z11. You know, this formula for Z11. That is open circuit impedance equal to Z11 in terms of Z parameters. What are the open circuit impedance at output port? The open circuit impedance at output port, then V2 by I2. But by making which port is open circuit, input port is open circuit. Then this is calculated as Z22. This is open circuit impedance. Then what is short circuit impedance? The short circuit impedance, students. The short circuit impedance at input port, V1 by I1, but by making V2 is 0. Actually, this formula is 1 by Y11. Y11 is I1 by V1. That's why it is equal to 1 by Y1. This formula is already given. Then what the short circuit impedance at the second port? V2 by I2. What the short circuit impedance at second port? At second port we are calculating means first port is open short circuit. Voltages are 0, short circuit. Currents are 0, open circuit. Then this is equal to which one? 1 by Y22. Because Y22 is I2 by V2. But I written V2 by I2 now. That's why it is 1 by Y2. These are the open circuit impedance at port 1. This is open circuit impedance at port 2. Open short circuit impedance at port 1. The short circuit impedance at port 2. Yes, friends. Now, what is the Z1 open circuit impedances in terms of the T parameters? I want to explain. Open circuit and short circuit impedances. Open circuit and short circuit impedances. Short circuit impedances. Short circuit means voltage is 0. Open circuit means currents are 0. Short circuit impedances in terms of T parameters. In terms of T parameters. What is the open circuit and short circuit impedances in terms of T parameters? Yes, friends. Then I am defining Z10. What is the Z10? You know that V1 equal to AV2 minus BI2. I1 equal to CV2 minus DI2. But you know that what is the open circuit impedance? Z10 at input port equal to V1 by I1. V1 by I1. Then from this, what is the V1 by I1? At I2 equal to 0. I2 equal to 0. Can you calculate V1 by I1 at I2 equal to 0? I am doing V1 by I1. What is V1? AV2 minus BI2 by CV2 minus DI2. But which is 0? I2 0. In this case, you substitute I2 0. AV2 minus 0 by CV2 minus 0. Then what you can get? A by C. This is the open circuit impedance at port 1 in terms of ABCD parameters, A by C formula. What is the open circuit impedance in terms of ABCD parameters? A by C formula. Next, Z2 naught. What the Z2 naught? Z2 naught equal to V2 by I2 at I1 equal to 0. At I1 equal to 0. Then you can write V2 by I2. You can calculate from this V2 and you can calculate V, if you want V2 by I2 students. If you want V2 by I2, take the I2 is common. Take the I2 is common. Then you can get V2 by I2. Then you simplify that one. Directly I'm writing. We can get D by C. D by C. Students, you can take I2 is common here. Then we can get V2 by I2. Here also V2 by I2. Then from these two equations, find the V2 by I2. Then substitute I1 equal to 0. Substitute I1 equal to 0. Then you can get D by C. Or simply, you want V2 by I2? Take this equation. Take this equation. What is I1 equal to? CV2 minus DI2. Then I1 equal to, take the I2 is common. C into V2 by I2 minus D into I2. But which is 0? I1 is 0. Take the I1 equal to 0. CV2 by I2 minus D equal to 0. Is equal to 0. Yes, sir. Now from this, what is the V2 by I2? From this, what is the V2 by I2? V2 by I2 equal to how much? D by C. Clear or not? That I am getting D by C. Okay, this is the open circuit impedance at the port 2. This is in terms of which one? ABCD parameters. Similarly, I want to calculate short circuit impedances. What the Z1S, the short circuit impedance at port 1. Z1S, how it is defined? V1 by I1. At V1 equal to 0. Sorry, V2 equal to 0. Then what is V1? AV2 minus BI2. What is I1? CV2 minus DI2. Which you want to make the 0? You can make the V2 is 0. Then 0 minus BI2 by 0 minus DI2. Then what you can get? B by D. Yeah, this is the short circuit impedance at input port, B by D. Then what the short circuit impedance at output port? This is V2 by 2, V2 by 2 at I1 equal to 0. Short circuit na at V1 equal to 0. Then you can take what is V1 equal to? AV2 minus V1 equal to minus BI2. Then take the V1 is 0. Take I2 is common. Then what you can get? A into V2 by I2 minus B. Then from this, what is the V2 by I2 you can get? V2 by I2 equal to B by A you can get. That's why what the short circuit impedance is equal to B by A. Clear, students? Yeah, this is the calculation of open circuit, very important for come. Open circuit impedance in terms of ABCD parameters, open circuit impedance in terms of ABCD at port 2, short circuit impedance at port 1 in terms of ABCD parameters, short circuit impedance at port 2 in terms of ABCD parameters. That is final conclusion I am giving. What the Z10? Z10 equal to A by C. A by C. What is the name of Z10, students? Open circuit impedance at a port 1. Z20 equal to, what the Z20, students? D by C. What the Z1S? What the Z1S? Z1S equal to B by D. What the Z2S, students? Z2S equal to B by A. All these are the open circuit and short circuit impedances at port 1 and port 2 respectively. In terms of which parameters? In terms of ABCD parameters. ABCD parameters. Yes, clear? Any doubts, friends? Yes. Now, sometimes it is asking ABCD parameters in terms of open circuit and short circuit impedances. ABCD parameters in terms of open circuit and short circuit impedances. For this, I'm not giving derivations. Directly, I'm giving, not required. ABCD parameters in terms of open circuit and short circuit impedances. Then A equal to plus or, by derivations only we can get plus or minus square root of Z10 by Z20 minus Z2S. V equal to plus or minus Z2S into square root of Z10 by Z20 minus Z2S. Z20 minus Z2S. C equal to plus or minus, by derivations only we can get this one, students. 1 by, based on this, no question in any competitive exam, but in future we may expect. That's why I'm giving these formulas. Z10 into Z20 minus Z2S. Sir, how we can get these formulas? Then by solving all these formula, this formula and this formula and this formula and this formula, by solving all these four relations, we can get this one. Then what the D equal to? D equal to final formula plus or minus Z20 by square root of Z10 into Z20 minus Z2S. Z20 minus Z2S. This is about the different types of parameters. That is ABCD parameters in terms of open circuit and short circuit impedances. Clear, students? This topic is also important. You please concentrate. The next one is how to define the input impedance and output impedance. This is very important. Already based on this model, gate questions also already framed. Input and output impedances. If you want to calculate input impedance, the input impedance is defined because at output side, if any load is connected, then input, how to define the input impedance? Input voltage is V1, input current is I1, then V1 by I1. Then if you want to calculate this input impedance in terms of ABCD parameters, in terms of Z parameters, okay, this formula you remember, direct formula. Or otherwise, we can solve some problems also. Without remembering this formula also, directly how to solve the problem, later on I will explain. Okay, this is the input impedance in terms of Z parameters. By giving the Z parameters, if it is asked input impedance, then use this formula. Then input impedance in terms of T parameters. Very important. Based on these formulas, already questions are there in gate exam. Input impedance in terms of T parameters. Input impedance in terms of H parameters. This formula is important even with respect to analog electronics point of view also. This formula you already studied in analog electronics also. Yes, the input impedance in terms of the H parameters. In terms of ABCD parameters, already question is framed in gate exam. Next, how to calculate the output impedance? To calculate the output impedance, then the load impedance is connected at input port. Then how to define the input impedance? The source is connected at output port. Then output impedance equal to V2 by I2. Then what is the output impedance in terms of the Z parameters? That you concentrate. What is the output impedance in terms of the ABCD parameters? Every formula is important, students. Then what is the output impedance in terms of the H parameters? Output impedance in terms of the H parameters. Yes, the output impedance in terms of the H parameters. This is V2 by I2. Okay, H11 plus ZL, H11 into H22 minus H12 into H21 plus H22 into ZL. This is the output impedance in terms of the H parameters. Okay, this we can define. The output impedance means load is connected at input port and impedance is calculated at output port. Output impedance means load is connected at input port and impedance is calculated at output port. That is nothing but output impedance. Clear, students? These are the different types of input and output parameters, impedances with respect to different types of parameters. Next. Then final concept with respect to two-port networks. Later on, I want to explain some important models. Image impedances. This is also important topic. Image impedances. So what do you mean by image impedances? When the two impedances are said to be image impedances. See, the image impedances for a two-port network is the impedance Zi1 seen looking into port 1. That means if Zi1 is seen from port 1 and port 2 is terminated by Zi2, then if Zi2 is seen from the port 2 and port 1 is terminated by Zi1, then this Zi1 and Zi2 is called image impedances. Then ZI1 and ZI2 is called image impedances. Is called image impedances. Clear, students? If we are seeing the ZI1 from input port, it must be terminated by ZI2. If you seeing the output impedance from, if you seeing the ZI2 from output port, then this impedance must be terminated by ZI1. Understand? That is ZI1 must be terminated to input port. Then only these are called which one? For example, ZI1 is 10 ohms. Then it is terminated by 50 ohms. Now I am seeing the 50 ohms here. Then it must be terminated by how much? 10 ohms. Then these are called ZI1 and ZI2 is called image impedances. That is called image impedances. Yes, friends. Now I want to explain, but I'm not giving the derivations. You please concentrate. The ZI1 is defined as V1 by I1. We can define this ZI1. Then what is the ZI1 equal to? V1 by I1. What the ZI2 is also, this is equal to V2 by I2. It is seeing from the output port, V2 by I2. Yes, friends. Then what is the ZI image impedances in terms of input and output impedances? Then where ZI1 is equal to V1 by I1 means, what is V1 by I1? That is equal to input impedance. That is equal to input impedance. Input impedance. ZI1 directly indicates the input impedance of port 1. That is input impedance it indicates. What is ZI2, students? ZI2 is defined as V2 by I2. What this V2 by I2 is called? Output impedance. This is the output impedance that I already defined. Okay. This is ZI2 is the output impedances. Now you see what are the image impedances in terms of T parameters. Image impedances in terms of T parameters. T parameters. This important concept here. Image impedances in terms of T parameters. Okay. What is the ZI1 equal to? We know that ZI1 equal to ZIP. ZIP. But you know the input impedance in terms of T parameters. What the input impedance in terms of T parameters? The input impedance in terms of T parameters. Yes, friends. The input impedance in terms of T parameters, A into ZL plus B by C into ZL plus D. A into ZL plus B by C into ZL plus D. But here in the calculation of image impedances, the load is not ZL, the load is ZI2. Understand, sir? During calculation of ZI1, load is ZI2. But during calculation of input impedance, load is ZL impedance. But during calculation of ZI1, load is not ZL. It is terminated by ZI2. That's why I'm replacing that one. A into ZI2, where ZL equal to ZI2 during calculation of image impedances. We know that during calculation of ZI1, what is ZL equal to ZI2? Because it's terminated by ZI2. Now I am replacing that one. Therefore, ZI1 equal to A into ZI2 plus B by C into ZI2 plus D. This is the image impedances in terms of the ABCD parameters. Similarly, what is the ZI2 in terms of the ABCD? ZI2 is the output impedance. What is the output impedance in terms of ABCD parameters? The output impedance ABCD parameters in terms of ABCD parameters, friends, DZL plus B by CZL plus A. DZL plus B by C ZL plus A. Now tell the students, during the calculation of ZI2, during the calculation of ZI2, load is terminated. Load is which one? It is terminated by ZI1. Now the load impedance is ZI1. Then you can replace D into ZI1 plus B by C into ZI1 plus A. That is during calculation of ZI2, during calculation of ZI2, load is where ZL is ZI1. It is terminated by ZI1. That's why I'm replacing ZL equal ZI1. Okay, this is the ZI2 in terms of the which one, students? Image ABCD parameter. This is the calculation of image impedances. Image impedances. Now, point to remember, by solving this ZI1 and ZI2, let this is the one relation 1 and this is the relation 2. By solving 1 and 2, directly I'm writing 1 and 2, we can get the image impedance ZI1 equal to square root of AB by CD. Very important. The image impedance ZI2 equal to square root of BD by AC. Sir, how I will get these formulas? By solving that 1 and 2. This is the ZI1 and ZI2 completely in terms of ABCD parameters. AB by CD, BD by AC. Then shall I write like this, students? What the ZI1 equal to? Square root of A by C into B by D. But what is A by C in terms of open circuit and short circuit impedances? Z1 0. What is B by D? What is the B by D? Z1S. That's why this is the image impedances in terms of open circuit and short circuit impedances. 5-star relations. Still now not framed, but you can expect. These models are not framed, but you can expect in future. Then ZI1 equal to square root of Z1, because this I already defined. What is A by C, sir? What is A by C? That I already calculated now. Open circuit and short circuit impedances. A by C equal Z1 0. Z1 0. B by D Z1S. Clear? Understand, sir? Yeah, that I calculated. Then I substitute. Then similarly, what is the ZI2 equal to? ZI2 equal to square root of B by A into D by C. B by A, this is a B by A into D by C. What is the B by A? B by A is the Z2S. Z2S into, that is D by C. What is the D by C? Z2 0. This is equal to Z2 0 into Z2S. Okay, this is the image impedances in terms of open circuit and short circuit impedances. Open circuit and short. But point to remember, friends, to define the two-port network completely, only image impedances are not enough. That means the image impedance itself completely will not define the two-port network. Because of that, we need to define the another parameter. That parameter we can get from the voltage and current ratios. This note I am giving. The image impedance do not completely define a two-port network. Hence, the another parameter is defined. Another parameter is defined from voltage and current ratios. Voltage and current ratios. I'm not giving derivation for that parameter. Directly I'm giving. What is that another parameter is? That parameter is called, yes friends, can anybody, what is that parameter is called? That is called image transfer constant. We are defining the image transfer constant. Therefore, image transfer constant, image transfer constant, because only image parameters will not define completely, is not analyzed completely. That's the reason why we are defining image transfer constant theta equal to, this fundamental definition for image transfer constant is half into ln of ln of my ln of minus v1 i1. By derivation only we can get this one, v2 i2. Then by simplifying this one, we can get theta equal to half into ln of zi1 plus zi2. I'm writing in terms of image impedances. I'm not giving derivation. Plus ln of i1 by i2. Okay, this is the image transfer constant. When by using image impedances and image transfer constant, then only completely define the two-port network. Then we can also write where theta equal to cos h inverse square root of AD. This is also equal to sin h inverse square root of BC, or it is also equal to sin h inverse square root of AD minus 1. Then theta equal to is also written as tan h inverse square root of BC by AD. By derivations only we can get this one, BC by AD. Is also equal to tan h inverse square root of, what is B by A, what is the C by D, that you know. That from that I am writing Z1S by Z2 Z10 is also equal to tan h inverse square root of Z2S by Z20, Z2S by Z20. Okay, these are the image transfer constant. Image transfer constant. This image transfer constant is calculated from the knowledge of Z1S and Z2S. By calculating is calculated from by knowing the short circuit impedances and open circuit impedances. And finally, the image transfer constant theta equal to 1 by 2 into ln of R plus j into pi by 2. By derivation only you can get plus n pi. All these terms I will explain. Then where n equal to 1, 2, 3 and so on. This is equal to alpha plus j beta. Alpha plus j beta. Yes. Where alpha equal to 1 by 2 ln of R. Where alpha equal to 1 by 2 into ln of R. Yes. This R and pi is calculated from knowledge of Z1S and Z10. Z1S and Z10. Then what is alpha, students? This alpha equal to 1 by 2 into ln of R. This is equal to image attenuation constant. It is called image attenuation constant. Image attenuation constant. Attenuation constant. Where beta equal to pi by 2 plus n pi. This is called phase constant. This is called phase constant. Where alpha comma, where theta is the complex quantity. Where theta is the complex quantity. That's why theta is which quantity? Complex quantity. It is a complex quantity. This is the real part of theta. The real part of theta. This is imaginary part of theta. What is the theta? Where theta is the transfer constant, imaginary part of theta. Okay, this is about what exactly a transfer constant and image parameters. Okay, these are the topics important with respect to two-port networks point of. Yes, students, any doubt up to now? Yes, clear. All these points you concentrate, and with this knowledge, I am giving some note points. Yes, students. Actually, for this case, I already given the Z parameters. Oh, sorry, ABCD parameters. What are the T parameters for this network? Come on, answer. I already given that. For that network, what is the T parameters? In the yesterday class that I explained, what are the T parameters for that network, for that type of network. If only series branch is present, what are the T parameters? Yes, 1Z01. 1Z01. Is okay? 1Z01. For example, mainly already Z parameters and Y parameters and H parameters also I given, but mainly concentrate on the T parameters is important. If it is like this, then what the T parameters? This also I explained. 1 0 1 0 1 by Z 1 1 by Z 1. If it is a Y, if it is a Y, if it is a Y admittance, if it is admittance, then what is your answer? 1 0. Admittance means 1 by Z is the admittance. Y into 1. Okay, Y into 1. Yes, friends, all these parameters that I already explained. 1 0 Y 1. For example, this is also important. This is the Z1 and this is the Z2. For this case also directly you can write the T parameters. Then how to write the T parameters in this case? All these formulas are important, direct formulas that you want to remember. How to write the T parameters. Yes, 1 plus Z1 by Z2, comma, Z1, 1 by Z2, 1. For example, this is the Z and this is the Y. Then how to write this one? This is the Z and this is the Y. Then how to write this one, students? Then T equal to, then how to write? This is the Z parameter and this is the Y parameter. 1 plus ZY, 1 plus ZY and Z, this is Y. Because Z2, you can convert this impedance into admittance. Z2 I am writing 1 by Y. That goes to numerator. This is Y and this is the 1. All these are the T parameters in different cases. This is very important. Please concentrate. Next. One more note point. To solve the different models of questions, these observations are important. For example, this is a transformer. This ideal transformer. Ideal transformer. And this is V1 and this is I1 and this is V2 and this current I taken, this is the I2 direction. Okay, this plus minus plus minus. I'm not giving derivation directly. Remember, what are the T parameters for this case? For ideal transformer, the T parameters is, yes friends, what are the T parameters in this case? The turns ratio, it is given that N1, N2, that is N1 is to N2. The turns ratio is N1 is to N2. Yes. I'm talking about what is the T parameters. Then if it is N1 and this is the N2, then T parameters is N1 by N2. By derivations only we can get N1 by N2, 0, 0, and N2 by N1. N2 by N1. Okay, the T parameters equal to, okay. Then what the H parameters? The H parameters is that you define 0 minus N1 by N2 minus N1 by N2, and this is N1 by N2 and 0. But for this network, we cannot find the Z parameters and Y parameters. For the above transformer model, above transformer model, because we don't get the V1, V2 in terms of I1, I2, I1, I2 in terms of V1, V2. That's the reason why for the above transformer model, we cannot define Z and Y parameters. Z and Y parameters. For above transformer model, we cannot define. For example, students, this is given like this. It is 1:n. This current is I1, voltage is V1. This current is I2, voltage is V2. Yes. Yes. Can anybody tell what is the T parameters and H parameters in this case? What is the T parameters? What are the H parameters? T parameters equal to N1 by N2. T parameters is N1 by N2. 1 by N, N1 by N2, 0, 0, N2 by N1, N. What are the H parameters? The H parameters equal to 0, minus N1 by N2, minus N1 by N2, that is minus 1 by N, minus 1 by N. Then N, next N1 by N2, minus N1 by N2, that is minus 1 by N, and 1 by N, 1 by N. Is it correct? The H parameters equal to, I given the formula, that is minus N1 by N2, N1 by N2. That N1 by N2 is 1 by N, and this is the 0. This is the calculation of H parameters. Yes, friends, that you please concentrate. Minus 1 by N, 1 by N, 0. For example, one more example I am giving. The same transformer. If the ratio is given N is to 1. This is I1 and this is V1 and this is I2 and this is V2. Yes. Now you can calculate what are the T parameters and what is the H parameters. What are the T parameters? N1 by N2, that is N, 0, 0. N2 by N1, 1 by N. What are the H parameters? The H parameters equal to 0 minus N1 by N2 minus N minus N, that is N 0. Okay, this is the H parameter. Use these relations to calculate. Okay, this is for ideal transformer. This is for ideal transformer case. Not considering any impedance, not considering input impedance or output impedance, all these. This is for ideal transformer, how to define the parameters. Yes. Clear, friends? Understood? This is the calculation if the transformers are given, how to do this calculation. And one more important network is very important. If it is, let's consider a lattice network. Lattice network. Let this is the ZA. This impedance is ZA. And this is the ZD. This impedance is ZD. Let this is the ZC. This is the ZC. And this impedance is ZB. ZB. This 1 dash, 2 dash. This network is the lattice network. But point to remember, if ZA equal to ZD and ZB equal to ZC, symmetrical and balanced lattice network, then symmetrical and balanced lattice network. Balanced lattice network. If ZA is not equal to ZD, or even one condition is not satisfied, ZB is not equal to ZC, asymmetrical and unbalanced network. Asymmetrical and unbalanced lattice network. Unbalanced lattice network. If it is a symmetrical and balanced lattice network, for symmetrical and balanced lattice network. Then what is the Z11 equal to Z22? Directly you can write the formulas like this. ZA plus ZB by 2. Z12 equal to Z21 equal to ZB minus ZA by 2. ZB minus ZA by 2. And if you do the Z11 plus Z12, Z11 plus Z12, what you can get? Z11 plus Z12 equal to this we can get ZB. Z11 minus Z22 equal to Z11 minus Z22. Sorry, Z1 minus Z12. What you can get? ZA. Just add these two, we can get ZB. Subtract these two, we can get ZA. Just that small mathematical calculations only that you do. Yes, friends, okay, this is about the lattice network concept that you remember. Okay. And one more important concept also, you please concentrate. It's also note point. For example, in a T network, this is the ZA and this is the ZB. Let this is the ZC. Okay, this is the ZA and this is the ZB and this is the ZC. We know that what is the Z11? ZA plus ZC. Z12 equal to Z21 equal to ZC. What is the Z22? ZB plus ZC. Now the question is, if ZA, ZB, ZC is given, how to calculate the Z11, Z12 and Z2? If Z11, Z12, Z21, Z22 is given, how we can calculate the ZA, ZB and ZC? Then if you want ZA, how we can get ZA, students? From Z11, you subtract from ZA plus ZC, you can subtract the ZC. We can get ZA. Then ZA equal to Z11 minus Z12. That are Z21. Clear? Like this we can get the ZA. What the ZB? How we can get ZB? To get the ZB from Z22, from Z22, from this Z22. If you want to get the ZB, you can subtract ZC. ZC is Z12 or Z21. Then what the ZC equal to Z12 or Z21. Like this we can. By knowing the ZA, ZB, ZC, how to calculate Z11, Z12, Z22. By knowing the Z11, Z12, Z21, Z22, how to calculate ZA, ZB, ZC. These relations also concept. Similarly for pi network, students. For pi network, which parameters we can easily calculate? For pi network, which parameters we can easily calculate? This Z12 equal to Z21. Y parameters. Okay, see, for example, this is the pi network. This is a pi network. Yes. Like this is the YA and this is the YB and this is the YC. Then you know that how to calculate Y11. Y11 equal to YA plus YC. What is Y12 equal to Y21 equal to minus YC? Y22 equal to YB plus YC. Okay, this concept. But by knowing this Y11, Y12 and Y22, how to calculate YA, YB, YC? Then YA equal to, if you want YA, from YA plus YC, you can subtract YC. But actually this is the minus YC. This is minus YC. Then we can directly add. This minus YC plus YC cancel, we can get Y. That is Y11 plus Y12 or Y21. We can do Y11 plus Y12, we can get YA. You can check that one. How to get YB? YB equal to Y22 plus Y12 or Y21. How to get YC? Is YC equal to minus Y12 or minus Y21? Minus Y12 or minus Y21. Like this. By giving YA, YB, YC, how to calculate Y11, Y12, Y22, like this. By giving Y11, Y12, Y21, Y22, Y2 calculate YA, YB, YC. Okay, this concept is also important. That also you concentrate, students. Clear? And one more important point. This is already given in the coupled circuits. If you draw the coupled for a transformer coupled circuit, if you draw the T equivalent, yeah, this is the T equivalent. For this T equivalent, let this is the L1 minus M into S. This is L1 minus M into S in Laplace transform. This is MS. Now tell me, what is the Z11 in this case? What is the Z11, students? Then Z11 equal to this plus this, L1 into S. What is the Z12 equal to Z21 equal to M into S? This is the, what is the Z22? Z22 equal to this plus this. that is L1 into S. This is L1 minus M into S. This is L2 minus M into S. Then what you can get? L2 into S. Okay, like this you can calculate. How to calculate Z11, Z12, Z2? This you can add, this two you can add, then this indicate the Z12 and Z21. Add these two, we can get Z11. Add these two, we can get Z22. This directly indicate Z12 and Z21 that equal to MS. M is the mutual inductance. Where MS means it is a Laplace transform. L1 into S, Laplace transform of inductance. Clear, friends? Yeah, that also you concentrate. These are the different models we can expect based on the two-port networks. You ready to answer? See, for example, if the question is asked like this, one example. Find T parameters. T parameters of the network shown in figure. Of the network shown in figure. Find the T parameters of the network shown in figure. Yeah, this is the given network. Yeah, this is the Z. And this is transformer. And this is Y. Then how to find the T parameters? It's very simple, students. Use the concept of cascading. For only Z is there, how to find that, 1Z01 into, this is ratio is given 1 n is to 1. Then for this case, how to write? Only for this ideal transformer. If n is to 1 is there, how to write? That is n is to 1. N1 by N2 is N 0, 0, 1 by N. Is it correct? Into 1 by N. If only Y is there for this one, parallel branch, how we can write? That formula also I given. Only Y is there. Then 1, 0, Y1. Multiply all these. Multiply all these. We can get the Y parameters. So we can get the T parameter. That is the answer. If H parameters are asked, if only Z is there, how to write the H parameters? How to write the H parameters for this one? How to write the H parameter for this one? That you know. Then directly you multiply. Then you can get the H parameters. Clear, friends? Maximum based on this one, we can expect only T parameters. For only series branch, this one. Only for this case, I already explained. N1 by N2, 0, 0, N2 by N1. That I already explained. Then only for parallel branch, 1, 0, Y1. Okay, that I given. Multiply all these, we can get the T parameters. Okay, like this, we can answer. Yes, friends, please concentrate. For example, this is the previous gate question. For the network shown in figure, find T parameters. This is a given network. This is the 2 ohms. The Z parameter network is given. Two, 1, 1, 2. And this is 1 ohm. For this case, you find the what is the T parameters. See, it is best method is cascading, but directly Z parameters are given. What Z is given? Z equal to 2, 1, 1, 2. Shall I write equivalent of this Z? 2, 1, 1, 2. This is 1, this is 1, this is 1. 1 plus 1, 2. This is 1, this is 1. 1 plus 1, 2. That means this I'm replacing this network as a T equivalent. This is 2 ohms and this is 1 ohm. Again it is 1 ohm. Sir, it is a 2, 1, 1, 2 is given. Sir, why you taken 1, 1? If you simplify this one, then only you can get this one. For T network, directly you can write the Z parameters. Na? Okay. Sir, why you are writing equivalent? Because I want to know the T parameters, means best method is cascading. This is 1 ohm. Sir, this network, this equivalent Z parameters I am writing as a network. And this is the 1 ohm. Okay. Now, this is 2 plus 1, this totally 3 ohms. This is 3 ohms. And this is 1 ohm. And this is 1 ohm. And this also 1 ohm. Yes, friends? Clear? Is it visible, students? Any problem? Yes. This I have the power cut. Is there any change in the brightness? Yeah. Now see this, you can divide into different networks. This is one network, and this 1 ohm and 1 ohm, and this also one network. Yes. Actually, this is 3 ohms and 1 ohm. This is one network. This is one network, and this is one network, and this is the one network. Okay. Then how to write this one? You know, it's just like Z1 and this is Z2. Z1, Z2. 1 plus Z1 by Z2. Z1, 1 by Z2, 1. And for this case, how to write this? You know. Then for this case, 1 ohm. Then you write the what the resultant T. This is TA, this is TB, this is TC. Then you write TA, TB, and TC. Multiply all these, we can get the T parameters. Yes, friends? Okay, that you try. Okay, this about in detail what exactly two-port networks. It is, if possible, in the next coming session, I will solve the questions. Otherwise, for time being, I'm going to starting the next coming session. I'm going to start transients. I want to finish that transients itself in the next coming session only. I will take 2 to 3 hours. Then I will finish the transients. That is the maximum ending session for the network theory. Whatever the remaining topic theorems is there, for that I will share the some PDF. You please concentrate that PDF. That is enough. With that, networks concepts will be maximum. It is completed, students. Okay. Thank you. This is about the today topic. In the next coming session, I am starting the transients. You don't miss that topics. It's very important. Transients also very important. Understanding the transients is very important. Thank you, students. I'm ending the session. Yes, is it okay? Thank you.